this local, they call it local refrigerator, but it's a kind of a cooler box. What is inside is the Flexiform, the Hessian sack, but preferably if one has the flannel cloth, it's better to use flannel cloth. So what happens is that everything here has to be weighted with water. You have to weight it with water. And then this must also be dipped in water. And then you can take your food and preserve it. It will remain reasonably cool. What is happening is that this particular cloth has the ability to evaporate water at a faster rate, at a better rate than the other types of cloth. So we use it so that when evaporation is taking place, we understand that the surrounding is usually kept cooler than it could have been. So the principle that is used in this one is that of evaporation. When evaporation is taking place in the surrounding, it's getting cooler. And then on top here, there is a hole to allow, if there is heat inside, if you close it, you have taken your food and you have preserved it, and if there is heat inside, we think that it can be escaping through the hole. So that's about the water. This, yes, to allow continuous capillary rise of water. That's why we do that, because we have to maintain the moisture inside so that continues. And then we have the sewing machine. This prototype sewing machine again was done by pupils in a class, and there were about 5 girls and 3 boys, about a group of 5 girls and 3 boys. Of course, the project had to last for 1 year, but at the end of the project, the pupils came up with this prototype sewing machine. It works very efficiently, and what the emphasis was on the lever systems that are in a sewing machine. So when they were making this, they were now able to understand how levers operate, and when we're teaching them in class, we are also using the very same sewing machine. As it's moving like that, you find that there are so many things. One goes the other direction, this goes to the other direction, and we were able to actually tell them the concepts of levers. And on top of this, I have the electric fan. There is the electric fan. Now this electric fan again was made by pupils, 2 girls and 2 boys, after they had looked at the real electric fan. And it works. able to get an old electrical motor and make a structure like this one and have it fun. But to get it actually rotating, it's usually not a very easy task. But after some trialing and testing, it worked. So that's the electric fan. And because of the type of works that the pupils are doing, sometimes there are problems in our country of floods. And you might have heard on the radio that maybe in Bangladesh floods are very devastating, and in certain parts of Africa floods are very but in Malawi again we are not spared this problem. And because of that, the pupils designed a device that can pre-detect floods. Now the device works on the principle of rotation. This bucket here, you see, I think you are able to see it. This bucket represents the river. And what happens is that when you're pouring water in the bucket, it is symbolizing the rising of the water in the river. And now at the end of the device, there is what we call the floater. And to the floater, it's connected to the positive terminal. And at the far end of the floater, there is this metal sheet, which is again connected to the positive terminal. This is negative, and this is positive. So what happens is that when the level of the water is down, this also goes down. But when the water is rising up, when the floods are coming up, this comes up and becomes in contact with this. And what happens is that when that happens, when there is that connection, then this is the flood monitoring station. It is believed that one can stay in this station, and when this is rising and the bell rings, the person manning the station can warn the people living in the flood-prone areas that floods are actually coming. But the design is in such a way that it has to give 3 warnings, because there is a tendency of rivers rising sometimes and then coming down. So if it gives 3 warnings, then you definitely know that the floods are coming. So that's how actually it operates. That's the first warning. And when the water keeps on rising, that's the last warning of the device. And we also have the microscope. There is the simple microscope. The belief is that microscopes are very expensive, and they cannot be affordable in many primary schools. I don't know about in Ghana, but in Malawi they are actually very unaffordable. So we all know possibly that the principle behind microscopes is magnification. So what we had to get was something from old cameras. We use old cameras. The lenses are the ones that act as magnifying glasses, and it operates on the very same principle of the real microscope. So if you can have time, you'll come and see it. And again, we have the hand-driven generator. We all know that maybe the concept of electricity is a very abstract one, and to have this concept, properly grasped by small kids is very, very difficult, Because if you talk of the generation of electricity, and then you don't involve pupils in activities that are generating electricity, it becomes a bit difficult. So this was actually done to be used in the concept of teaching the generation of electricity. So you can come if you have time and again see. And besides this, we also have the toilet system. Many people go to the toilets, but they have never actually asked themselves the question how the toilet system operates. Maybe we all know that the toilet system operates on the principle that systems are siphons. So what is in here is this acts as a bucket, and this is the system, and there is a small test tube. If you open the system, you find there is the bell jar. Is it the bell jar or? Yes, there is that bell jar. Now when water is in the system, when the water is put in the system, you find that in the test tube there is actually no water, and when you make it to operate, that's how it operates. You can see that the volume of the water in the test tube is not changing, whilst the volume of the water in the test tube is actually, in the system, is actually dropping down. And there is a lot of, explanation on why that happens. You find that the level in the system is going down, whilst the level in the test tube is not actually changing. And this usually fascinates the pupils. They ask quite a lot of questions. Why is this happening? And so many other questions. Maybe before I continue, you may have some comments and questions I can take before I demonstrate the other things.
My question is on your cooker.
Yes.
How long can you use your heat to boil my soup?
Yes, we can take this approximately. If we use 750 milliliters of paraffin for possibly 5 kilograms of sand, you can cook your meal very, very well. But meal for 2 or for 3, it works. 5 kilograms of sand and then 750 milliliters of paraffin, it works. And if it's tea, the water boils very, very fast.
And we're talking of the maize straw.
Yes.
What is it? How long will that last?
Okay, if we take the maize bran and put it in here, it is going to be a different setup, because what we do with the maize bran is to have it in a powdery form, and then we have again something like this, but you will make a very rectangular hole at the base of the tin, and then you take the You take your maize bran and try to put it there, or else it's very, very hard. And then when it has come to the brim, try to release it very slowly. You release it very slowly, and then create a convection of oil between this and that, and then you just light up your fire, and it can stay, or it stays for almost 24 hours. Then, yes.
From the problem of conserving energy, we're using a metal pan. I do not conducting it away from our water. We find a way of conserving energy so that we surround the metal pan with a felt or something, a poor conductor.
Yeah, of course, in our homes what we do is we have the metal thing, and then there is this locally constructed ovens. Yes, earthen ovens. I think you know what I mean. Yes. So others use it that way, but others in towns, they just use this one and put it at the corner of the house, and they are fenced. Because the problem with the maize bran is that it produces smell. There is a certain smell that the maize bran produces. So many people prefer to put it at the corner, and then they just go to attend what is happening. So that's the only disadvantage. But it burns very efficiently, more than the sun. Yes. Another question? All right, and then I have toy car. But maybe before I come to this one, let me just complete. From things. Now this is a switch. This is actually the switch, but the construction of the switch is such a way that you have the two cardboards, the way you see them, and then you take a flexafoam. The flexafoam is pasted at the end of the two bolts. And then there is a wire there, that is the one on top and the other one below it. Why we use the flexafoam is because it's very silent. So what you do is you take, after construction, you connect it, or you solder your connecting wire, one on top and the other one below it. So you can take this and put it at your doorstep at home, and cover it with the doormat so that it is completely concealed. Now what happens is that when the burglar comes, you can make your own choice, either to have the bell in your house or outside to scare him, whatever. So I can invite one to come and be a burglar. Okay. When you step on it and the bell is in your bedroom, you can actually know that somebody has come in the house, and you can raise an alarm bell. So as you see, you only need batteries, about 6 volts batteries, and so you can use it in the villages and the local areas. Yes.
Can I ask a question?
Yes.
There's a possibility that most dogs are very intelligent.
Yes.
I wouldn't come by the door. I wouldn't come by the window. That's the first of town they come to the house. They come in 2 minutes. They break 2 minutes.
Yes.
That's the first thing. The second thing is that these days, everything is important. And I take drummers from my job. So the government has the best thing, they don't have people.
Okay, anyway, we are working on using magnets. You know, using the very same question was asked by someone to say, usually burglars are very clever sometimes, but if they're going into the house, they would want to steal a refrigerator, right? There will be a way of them coming through the door. And many thieves, what they do is that if they want to go into the house and steal big, musical instruments, what they do is they enter into the house, find a way of getting out through the very same door, and you can be waking up to say, okay, there is someone who has come. But to cover for the windows, what we are again trying to do is to use magnets, to have a full circuit. The other one, having is solenoid, and then the other one, so that when the burglar breaks the circuit in the other, I think you understand what I'm saying. When the burglar breaks the circuit in one of the others, then there is a small spring that is actually goes back to the others and complete the circuit, and then the alarm can still be raised. There is that provision, but we are trying to make it better. It doesn't work the way we want it, but we are trying to make it better. But certainly, yes, burglars are very clever. And it is accessible in bigger cities of Blantyre, Lilongwe, and Zuzu. So those of us who are living in the remote part of the country, we usually don't get the signals. So one day, one member of the club just came and said, sir, I have designed a satellite that is able to pick up the signals of radio 3FM. And then he came and demonstrated what he was doing. And when we tried to test it, it worked very efficiently. And when we were trying to take off this wire from the radio could not pick up the signals. And when we could put it, it was able to pick up the signals. Now at that level, we then tried to find out what the material is. What is here is the magnet from an old speaker. That's the magnet. And then there is these metals. I think you all agree with me that what is here is actually the magnetic field. And so one wire, this one, is connected on top of the magnet and goes to the longer wire. And then there is this one that comes in contact with the metal wire. But then construction should be made in such a way that this magnet and the metal plate, they should not come in contact very easily until somewhere there. So what happens actually is that we were trying to, then I tried to make the pupils understand that when an announcer is talking on a radio, say Radio Ghana, what usually happens is that the waves are changed into electromagnetic waves, and then it puts parts of electricity and they are spread out to the rest of the country, and then they are picked by radio antennas and changed back into electromagnetic waves, and then they are changed into sound energy by the speaker. So actually we had to make the pupils understand that concept. Though it was not at their level, but still they could understand. And we also have pupils that are actually coming up with small radios, and the other things. So basically, that's what I can say on the simple electronics. Yes.
I don't know whether you're going to tell us that you use it to demonstrate how the real freight works, or it can actually present for maybe 2 or 3 days.
What I'm demonstrating is that it preserves full preservation. We know we can preserve food by either drying or salting, freezing, and the other methods. But sometimes by cooling, we can also preserve food. Yes, because the one we have is a bigger one. It has, I should call it drawers, it has sections. The upper section, and then the bottom section, 1, 2. So what we do is you can take your vegetables and put them on top. You can take your tomatoes and your meat, put them there, they remain reasonably cool for the next 24 hours. And if you are trying to preserve milk, then make sure that at intervals you must boil your milk, put it there. Boil it, put it there. But things don't actually get frozen as we know the other refrigerators. Yes. That's what happens. Yes? My question is, are we going to write out on each of the yes, I have. Yes.
It looks like the concepts that are being taught are well advanced. We can see levels, we can see principles of rotation, and so on. Do you have occasions on which these are really sent to classrooms for demonstrations?
Right. On rotation in grade 6 in Malawi, we actually teach. There is a topic on air. There is a topic on water. And in the course of the topic, if say we would like to differentiate to the pupils that between water and air, which is heavy or which is light. So in that context, we have to carry out an experiment to demonstrate that air is lighter or water is heavy. So we get a balloon, inflate it, and get water, put it in a bucket, and then take the balloon on top, and then you find that the balloon is your water. And we make a conclusion, say, okay, air is lighter than water. Now, it was from that, when we were trying to come up with the device, because we had used maize pith. I think you know what a maize pith is. We had used the cork, but then what was happening with the cork was it was not accurate. Sometimes it would go and sometimes things like this. And then the maize pith, at certain times it would suck a lot of water and sink. So what we had to do is to find something that is, that can remain stable in water at a prototype level, and it was the balloon, and that's why we used it.
What I want to point out is, do you have occasions on which all these are found in the school curriculum?
Yes. For example,
they are not out of curiosity. They are not coming just out of curiosity, but they are part of the school curriculum.
Yes. For example, when we are teaching machines, examples of machines, I take the fan, the sewing machine, as examples of machines. Yes.
Yeah, these are all local materials.
Are there any occasions you have to buy some of them, or everything is obtained free? You don't buy anything. And if you buy, how do you get the funding for purchasing some of these materials?
Many of the things you see here, the wires are the ones that the pupils collect from steel, what do I call them, steel scrap areas. And these motors, most of the motors you see here, I'll give you an example of this one. These motors are those that are actually thrown away by radio repairers. And then they go and ask for them to get some. But however, at one time, we were very fortunate, that we had an exhibition before the head of state. So he gave us about $250. So it's when we tried to structure some of the things, and it's the money that we are actually using, but we don't actually get funding from anywhere. Yeah. So many of the things we are actually using them in class. We are actually using them in our day-to-day learning. And as I was saying, these are just club activities, but they are school classroom-based activities where we use pupils to come up with teaching and learning materials from the environment and use the very same teaching and learning materials to teach them, certain topics in the school. That's what we do. Yes?
Yes, I'm just going on the topic with rotations. I wanted to demonstrate 5 shapes or shapes and fruits. Well, we decided to give some specifications to a carpenter to design a shape for you. Yes. Now, what would be the difference between a shape designed by a carpenter and a shape designed by the teacher himself or herself for this kind of teaching? I'm asking this question because when you tell the carpenters and other people to design things for us, especially the non-basic, writing the applications for the rest, and that is wrong. And I want to know if you have got that experience, in which case you'll be able to see why we do things to carpenters and we do them ourselves. So I want to know if you have that problem. So I can share my experience.
Yeah. Students are taught to design experiments. There is, of course, that problem. And I remember the time, one occasion, but I was not necessarily doing something on flotation. But we had taught the pupils to design their own experiments to find out which structure can hold the highest weight using straws and the other things. So, yes, I would say I've also experienced the very same problem, but at the end of the day, we still sit down with the pupils and tell them, I should use the word tell them, that this is right and this is wrong. But actually it is them who decide, and then from what they have designed, it's when we draw up conclusions. So this is right, this is actually wrong. But that experience is there. Yes, it's there.
Yeah, if I could just add to this, maybe more specific, I would say that if you should take a shape, for example, it's a master of it.
Yes.
And it has stability as well, especially in hardware. Now, if you keep using it, the capital that has the concept of buoyancy, concept of buoyancy, and the concept of center of gravity, and all those things. When you guys teach about these concepts, you need to design something which is such that it is not quite the way below, and the center of gravity is quite low. And that if it kills, just move sideways, that the flame force will move along the line of force beyond a point beyond the center of gravity.
Yes.
So at this point, are very, very crucial. If you give it a carpenter, it can be a very beautiful thing for you, but so sometimes improvised materials can rather be strong scientific concepts as you to teach them. and might be better way not to use them. And if we're going to use the global business, we must be careful to make sure that the concepts are properly encapsulated in the materials. So those are the point I want to address.
Just to add on what you said, when we were using this thing or this as a floater, we had the very same problem, as I've already said. But to maintain, the concept, to have the concepts of science, very well maintained, that's why I had to come up with this. And then there is what is called the floater guider. This is the floater guider. So that this is actually there, and then when this is floating, it has to go straight like that. And it is also, anyway, but it must be, the shape must be very round, so that it is floating in the floater guider, it goes straight and down, it goes straight and down. So to have those, concepts very well, grasped, we use, I should say, gimmicks like these ones to make sure that things actually work. But definitely those are usually taken care of.
I will add one control. Some of these materials so that we can teach our children in their house. The components, okay, of some of them which are very simple, so that we can teach them in their house.
Okay, the components are very simple. Sometimes where the school is, influences the type of activities that pupils actually undertake. While you see a lot of wires, there was a construction company that was building a large wire along the former head of state in Malawi, Dr. Hastings Kamuzibanda. They were actually constructing another wire. They had another wire before, but then they had to take that, wire out, and that's why there were quite a lot of wires, being thrown out, and that again influenced the type of activities that, the school has. So the materials actually can be sought within the school environment, depending on what you want to do. For instance,
we want to make a standing fan.
A standing fan,
so that we can rotate by using the batteries to connect to make the circuit complete.
Okay, you can use two motors, two all the radio motors, and you can have two odd radio motors. This one is usually stationary. This one must be stationary, and then you have this one just at this angle. Anyway, there is no specific measurement as it must be maybe 25 centimeters or 30 centimeters. No, you just have to look at it and say, okay, this is at least a very good. So you must have this one, and then a structure like this one, so that when this one is rotating, it should be pulling that, just like that. I can also give you an example of the mat. This is a tester, okay, which was again designed to be testing, electrical circuits, but using the motor. So what happens is, if the circuit is alright and then you connect it, this motor will usually go around and it will tell you that the circuit is alright, is okay, as it is going around. Yes. Maybe have I made myself clear? Okay.
Can I know how the clubs are organized? How do you organize the clubs? And you have a lot of patronage from your people. So I think it's very popular.
Yes, organizing activities for the club sometimes is very demanding. Very demanding if you want to come up with something. First of all, what happens is the club, there is usually an announcement at the beginning of the school session that we are going. We need those who are interested to join the science club. So the pupils actually meet. When they have met, and then they decide, they elect office bearers, chairman, treasurer, and then they make a recommendation to the head to have their patron. And so it's actually the recommendation that comes from the pupils to say, we want so and so to be our patron. And then for them to become fully members, they are actually obliged to pay a small amount of money. So they pay their membership fees, but attached to the, for one to be a full member of science club, we make sure that their classroom performance in the science and the mathematics is well over 75 and above. If less, of course, they are given time to catch up and see what they can do. But that's what we do. And every test that they write in mathematics and science is actually recorded. So in the club itself, there are so many activities. They are involved in what we call public service involvement. For example, there was an outbreak of cholera in Malawi. The club was actually used to disseminate information, sing songs on the prevention of cholera, designing posters, carrying out drama and the other things. And we also have projects, different projects. And since we've got different age groups, we also try to encourage those that are in grade 4 to be doing a kind of hands-on, science type of activities, and they try. But usually the centerpiece is the public service involvement, projects, and there are so many projects, there are so many categories. This is what we actually do. But the teacher must be with them. Yes.
I believe you spend a lot of time on this.
Yes.
How do you manage that? What sort of schedules do you use for that activity?
Yeah, on the school timetable, we only have one day for classroom, for the whole school. We only have one club day, that is Tuesday. But anyway, to come up with the projects, we give them, if they have come, then the pupils are usually put in groups. Now it is these groups that must find their own time to wake up, so that on the next meeting in the other week, when they've been given a project like this one, they usually require to submit the write-up of what they are doing, and they're usually deadlines sometimes. We give them deadlines that by such a date, you must be through. So sometimes they will come even on Saturday and on Sundays to work on their projects. But this, whatever they do is accompanied by their write-ups, what they have gathered, what they have done, and what the results are. That's what we do. Yes.
We go back to what Mr. Mendeka asked. Most of these hands-on activities usually are not related to what academic performance in the class. Some can be very good working with their hands.
Yes.
Now, if you are going to use somebody getting 75% upwards, what about maybe somebody who is getting low marks in academic basis, but can be better than somebody who is getting 100%? Do you think, how do you do that?
What you're saying is true, because to balance that, we have had yes, they are in my write-up. We have had 2 boys. They are very good at making these models. But if we look at their performance in class, in the other subjects, they don't do far much to the expected average. But what has been amazing is that when we started, when we started them with the activities, they have been trying to catching up, but not to that satisfactory standard. But it is at least better than before. But what we do is to keep on encouraging them. And as I've said, this is a part of the work. We do academic work in the club. Wherever they have problems, they have difficulties, we do them so that we can see where we can go. So we actually help them a lot. Yes.
I want to ask him a question, which was asked. With all these activities, do you yourself find time to do it? And are you well paid for that?
Yeah, in fact, what's the amount of money I receive in Malawi is about $20 a month. 20 years, about 20 United States dollars. That's the money I receive. And anyway, what I do is my program, my personal program, starts at possibly 4 o'clock every day. Then at
in the morning,
4 o'clock, wake up, do some my own house keeping. Then at half six, I start teaching, because I'm teaching in the last class before junior secondary school and the other class. So we start at half six. And from half six to half seven, what we learn is science. That is academic, pure academic in the class. So we learn some every day, up to possibly Saturday, when we deem it necessary. And we do that kind of every day. And with this kind of interaction, from the results we had last year, there is a remarkable improvement, both on the part of girls and on the part of boys. Because we had 67 pupils sitting for primary examination, and about 65 passed, and 50-something were selected. And since they have introduced what they call community secondary schools, and all the other number of those that passed the examination, they have gone to the community secondary schools. But looking at their grades in mathematics and science, no.
It's not official. The school starts at 7:30.
Yes.
So 6:30 to 7:30 every day is his own contribution for no pay. That is the part. He does it to tell. So he's so excited that the results of the pupils have reflected on his own contribution. I wish we can start that here.
It doesn't help me very much, because when you talk about $20 in the US, it's a peanut. But when you talk about $20 in Ghana, it's a lot of money. And in other words, if you understand the any particular place, it determines. You don't need to leave your house to go to a place, so don't spend any money. So if you talk about the amount you receive in terms of your living standards, would you say you are comfortably, living? Yeah. Because the money is the value is
yeah, of course, no, but besides, because some of, as we were saying, we were taught not to ask, to tell people to make any contribution in anything at school level. Now, to have things work, it's really tough going. Though I was saying they are supposed to pay membership dues, but none paid, and we don't say, because we are afraid that the government can terminate our services. So, what we do is we say, okay, if that is the situation, then what is the way forward? So it is actually a personal sacrifice, and as you have said, I was just saying it for the sake of people to know that Yes, that's what is happening. But despite that, we are happy. And when we see pupils pass their examination, no, we are very, very happy. Yes, that's the kind of reward that we get. For example, there is one kid, who was a speaker of the club last year. Yes, when he was selected to a national secondary school. And I happen to have met the head teacher, the rector, because it's a Catholic secondary school. And when I was questioning about, I think you have received this chap, what is his performance? He was saying the performance is super. And I requested to have the report card. It was he is number one, and he's on the quiz, team of that particular school. And he's very brilliant. And it's not the only one. There are quite a couple of others, that are doing better. And when I look at that, I say, wow, that's possibly my contribution, and God be blessed. That's what I say.
And the next thing is there are a lot of electrical gadgets here. And in the club, forming the groups, what's the ratio of girls to boys? Because we are all worried about the girls not being interested in. Apart from this, how do they relate in the other activities, the girls in your school?
Okay, when we started the club, there were only 5 girls. But then with time and trying to popularize this, when we invite parents to come and look at the work, when we invite government officials to come and look at the way, when they could see their friends explaining that this works like this works like this, and that kind of interaction, those activities, encourage the other girls to join the club. And as I was saying, they have had the projects on insecticides, and that is not the only alternative energy source we have. We have the use of solar. We have solar cookers, and we also have solar cookers, fruit dryers, and we also have many things that possibly are related to girls. So we do have activities, of course, related to girls to make them at least come closer, so that when they come, then we can put them in the other groups. And as I'm talking now, the number of girls is more than that of the boys. Because as I was saying, when they were making the sewing machine, I deliberately had to assign 5 girls and 3 boys. And they were responsible for the collection of the materials. And whenever they wanted to straighten up the wires, they could do that. Yes.
So if there is a training budget,
I would say I only had to go to a teacher training college, qualified as a teacher. That's all. And then from there, through my own initiatives, and that's what we're trying to do. But however, now we are trying to get the student teachers at this, because I'm at a demonstration school. So we do have time with the student teachers to share these experiences and see how they can do in their own schools when they graduate.
that is implied you are the only one who is in the US.
As of now, there isn't, I don't know. Maybe the other schools they are doing science club activities, but with the publicity that we have tried to have this replicated in the other schools, others are trying, but they say they don't find the time. That's what they say. Yes. No, I wasn't trained. We just sat and say, okay, after maybe reading from different books that science is not popular among his, Malawian kids. And you usually find that some of the things that are usually done, they concentrate on secondary school and to the other level. But the basic level is usually forgotten. So we just started like that. But however, we are still struggling, but I wasn't actually trained. But we just started organizing up to what we've done.
But regarding those who are taking sides, it's still the same. I don't know whether this activities end at the same time, just the primary school, or we are making moves to extend to the secondary level.
Yeah, one time we had what we call the night secondary school, or junior night secondary school at my school. And I had pupils that I was doing these activities who had gone to this night secondary school. And I was teaching at this junior secondary school that time, though the government later on had to say it's illegal, and I had to be fired for 6 months. When they realized that I was not wrong, then I was reinstated. But at that time, we had to actually have the same group doing junior secondary school activities. And we had so many activities that time on days, had projects on days, and the other things. So they actually, yes, go on like that. Yes, the number that is those that are taking science, yes, has been increasing. Is increasing, is on the increase than before, more especially on the girls. But money is a problem. Yeah, you come up with a book. Anyway, I might write up that all the kids are doing this. That is, yes, that I have. But to write a book, when I say, I can't manage.
Down one capacitor, resistor, and your earpieces, and your radio using series have a simple. And you only have the that's it. But if you use the battery, so what you're doing here is the connectivity is very static, but make sure that the two parts, the part of and this one is not coming in. They have to come in contact somewhere along your wire. You can choose anyone. Or even you can, if you don't have a TV and if you have a TV, if you take the wire, take off the antenna, get a fork, right? You go ahead, you get a fork, just put it, you just have to put it somewhere closer to where you jack the antenna. You can pick up the television. But sometimes with no sound. Yeah, of course. Some people we do that. Right? We cannot manage to subscribe to television station. But it was yeah. But then if you look at that, what you're doing is you are changing the stars of electricity. You're changing those waves. Trying to make them be pictures of reality. So if you understand that kind of movement, it's very easy for you to understand. So the campus is well above all the other buildings. So we get assured that we cannot be smashed or you mean this? But if you look at it, it's very silent.
Thank you very much. We have shared experiences, but this should not be the end of these experiences. I've had a chance of seeing Ghana, and you are better. There is a lot of junk, as you will say. These materials, we usually get them, those that have been thrown away. And the guys in Japan thought it was rubbish, and they are the very same materials we can actually use in the teaching of science. So my word is that let us popularize science, more especially at the basic level, so that there is a generation of scientists in the future. That's what I can say. But I'm wishing you all the best in your undertakings, and God should bless you. Thank you very much.